In this video, we are going to look at different vocabulary of polynomials. These vocab terms are going to be extremely important for us to be able to complete the rest of the unit. So the first thing that we're going to be looking at is what is a polynomial anyway? These expressions below here, all of them, are polynomials. What they have in common is that we really don't see variables in some odd spots. What I mean by that is we just have the variables attached to coefficients, even if those coefficients are fractions. And in some cases, we don't have variables at all. We can have constant terms, so terms like -29, which are just a number. They could be polynomials as well. What's important is that we understand that some of these expressions are not polynomials for very different reasons. So for instance, the first one, we have 5 divided by 2x plus 7. This one would be considered not a polynomial because of the location of the variable. And this one, the variable is in the denominator. So that's going to be a concern for us because it won't give us a nice smooth curve. There's going to be some breaks somewhere along the way. The second one, the square root of 4y plus 8, is also not a polynomial because we're taking the square root of a function. 2 to the x, an exponential function, is also not considered a polynomial. The variable is in the exponent. Log base 3 of z is not a polynomial. Log functions would not be considered polynomials. Same thing with sine of z. That one would not be a polynomial. Although it is a smooth continuous curve, it doesn't quite fit the characteristics of polynomials. And then here, negative 2x to the 2/3 power would also not qualify because we have a fractional exponent. We need whole number exponents. What this essentially means is that we're going to square something and then take the cube root. That won't work. And then that 9 to the 3w plus 4 also doesn't work because of the variables in the exponent. So the next thing we talk about is standard form. And standard form we only consider in polynomials if we have one variable. And what we're looking for are any like terms to be combined and them to be arranged from the highest degree, so that's the highest exponent, down to the lowest degree, which is the lowest exponent. These are examples of ones in blue that are in standard form. All like terms have been combined, and we have our highest exponent first, followed by our next highest, and so on, all the way down to potentially a constant term. But the ones in the bottom are not considered in standard form. And the main reason why is that we haven't put them either in descending order, like this one right here, the 4x to the third should be in the front, or we haven't combined any like terms. So here, potentially, we could combine like terms. We're going to need to distribute that out. We don't want any parentheses or anything like that when we're talking about standard form. And this third one here, we didn't combine the like terms. So that's a concern. So let's just practice one here, rewriting it in standard form. I'm going to take this more challenging one here, the one in the lower right. So to do this, I need to get rid of the parentheses. I'm going to really treat this as a -1 in front. And I'm going to distribute that -1 to the three terms that are inside. So I'm going to have 12y squared minus 3y minus 4 plus 6y squared plus 12y to the 6th. So I'm kind of going to do a 2 for 1 here. And what I'm looking to do is start off with my highest exponent, my highest degree term, which would be that y to the 6th. So that's going to be my leading term. I'm going to start by just kind of listing that out because there really is nothing that's going to combine with that. So this guy right here is going to go right in front. The next thing I'm looking for is my next highest degree, my next highest exponent, which would be 2. And these are like terms here, 12y squared and 6y squared. They have the same variable and the same exponent. So add those together gives me 18y squared. And then -3y has nothing attached to it, so it's just there. And then -4 goes at the very end. So this is considered in standard form. All like terms have been combined, and we've put them in descending order from the highest exponent down to the lowest exponent. So we have some different types of polynomials. Linear polynomials are polynomials that are degree 1. The highest exponent they have is an exponent of 1. Quadratics, we have a degree of 2. The highest exponent we have is 2. And again, that's written in standard form. The next highest is cubic. Cubic is a degree of 3, 5x to the third plus 5x plus 4. Highest exponent is 3. Quartic are degree 4. So we have 6x to the fourth. That's our highest degree term. So that would be our degree. We call it a quartic. And then anything else we consider an nth degree. So we don't go any further than calling a fifth, a sixth with any special names. There are names out there, but we're not going to really use them much. So the next thing we want to do is take our terms, put them in standard form, and identify whether it's a linear, quadratic, cubic, or quartic polynomial. We've already practiced standard form, so really what I'm going to look to do is identify which type of polynomial we have. So what I'm looking for is my highest exponent, which in this case on number 5 would be that 3. So this guy right here. Because I have a highest exponent of 3, I'm going to call that a cubic polynomial. Number 6, I've got a 2 as my highest exponent, so that would give me a quadratic. Number 7, I've got an x to the fourth, so that would be a quartic. And number 6, the highest term I have is that 18x, so an exponent of 1. That's considered a linear polynomial. And you might think linear sounds like line. It's exactly what it is. So some vocab terms that we need to know. So again, we've already talked a little bit about standard form. Standard form is when we combine our like terms, put our highest degree first. This polynomial has 5 terms. So terms are separated by the pluses or minuses. So again, these are kind of dividers. And I've got 1, 2, 3, 4, 5 outside of those dividers. The degree is told by the largest exponent, which in this case is 4. So that's our degree. The leading coefficient is the coefficient on the first term when we are already written in standard form. So based on the original problem, it appears that the lead coefficient is 13, but that's not true because it's not written in standard form. And then we can look at each of the terms. The quartic term is considered the one here with an exponent of 4. 5x to the fourth is the term. The coefficient on that is 5, but the term itself is 5x to the fourth. The quadratic term is 7x squared, and the coefficient on that is 7. And the cubic term, by the way, would be 13x to the third with the coefficient of 13. The linear term would be negative 9x with a coefficient of negative 9. The constant term would be the one that has no variable at all. And think of it this way, it's constant, it can't change at all. So that constant term would be negative 6. So those are some terminology, some things that we need to know about polynomials that will help us in our further studies when we get to the further sections.